Welcome to a demo of DataBuck. DataBuck is a unified data observability and data trustability platform that can autonomously validate data at all. It uses machine learning to validate data at 10x less effort and 5x greater accuracy. It populates data trustability scores for every dataset to your data catalog with its open API design. This demo will show how DataBuck can be used for autonomous observability of the data lake and how it can validate the trustability of the files that arrives in the lake. Here we have a data lake named Azure Demo. It has a folder called Customer Loans, to which we'll upload a new transactions file. DataBuck continuously monitors the data lake for new objects that arrive here. It identifies that cl.csv file has arrived and does the data observability checks. Let's take a look at the results of the observability checks. We see that the loan transaction table has received some additional unexpected files. Clicking on the details, we see the additional files. DataBuck can alert and stop the pipeline depending on the seriousness of the issue. The latest file did not have any issue with respect to volume and schema. DataBuck intelligently determines the expectations for different file arrival times, arrival frequency, the volume and structure of data, for every folder and subfolder automatically without any human input. This will reduce the effort and cost to monitor thousands of files and tables. Once the basic metadata-related observability checks are performed, DataBuck then does a rigorous trustability analysis. Using thousands of micro-fingerprints created using machine learning, DataBuck will look beyond the metadata and into each file and into each record to determine the data trustability score. To review the detailed data trust results, let's go to the Results menu. From the Home button we can click on the Results drop-down menu and pick any of these four options, from observability all the way to matching. Clicking Data Quality or Trustability opens the Executive Summary page. It shows the evolution of aggregate data trust score for an entire project, that can even have hundreds of files and tables. Clicking on the From and to Date, you can pick and choose where you want to zoom in. Scrolling down, we can also see the aggregate data trust score for files and tables that contain customer data, product data or transaction data. On the top, clicking the Data Validations tab, displays more information on the tables. The data trust score for each table is displayed in the DTS column. Click on any of these to further drill down and look at what caused the data trust score to be high or low for an individual dataset. Doing that gets us to the table level results. At the very top is the aggregate data trust score or DTS for this specific table. This is a very powerful metric to communicate the trustability of this dataset. Tracking this over time, you can catch short-term fluctuations and long-term trends to data trustability and data quality. Clicking the lens icon at the top left gives information on the data profile. There are multiple tabs listed here. The column profile gives basic column information. The blue funnel on the right-hand side will list more detailed profile information available to the user. In the column combination profile tab, information on inter-column relationships are displayed. The tab column correlations show the numerical correlation between all possible columns. Profile is a default feature in DataBuck that does not need any user input. Scrolling down, on the left column are listed the different dimensions of data quality that have been checked. Listed in blue are the checks that DataBuck classifies as essential data validations. Further down, checks in red are the more advanced data validation checks. They align with the SMEs and business user interests in different kinds of anomaly detection. The record count for this table is listed at the top of this dashboard. It's about 4,000 records. With no human input, DataBuck automatically determines which columns are to be checked for which dimensions of data quality. For example, here DataBuck automatically recommends that the null check be applied on a few specific columns. Click on the number to see the different columns that the software is recommending for null check. It's worth noting that DataBuck identified all the relevant checks without any user input. This eliminates over 90% of the effort needed to maintain good data quality. This enabled a financial services organization to establish data trustability for over 15,000 tables in less than 2 weeks. This activity would have traditionally taken them a few person-years of effort. Let's deep dive into a few of these data quality dimensions on the left. Clicking on the null opens the tab for the null check. Listed in the column name are the different columns that have a few nulls. There are a few magical things the software does. First, it auto-recommends the columns on which this check must be done. It also auto-recommends the threshold for failure for this specific column for this specific check from the historical performance. For example, for the zip code the null threshold is automatically recommended to be 1% in line with historical expectations. And for the customer government ID the null threshold is set at 0%. Clicking on the customer government ID we see the historical runs and how this column has performed for nulls. The user can override the software and teach it what the acceptable threshold should be, by clicking the thumbs down symbol. You can recommend the right threshold and the software will learn from your feedback. You could also decide to include more columns for null check by clicking on the plus icon, or you can disable null checks on the auto-recommended columns by clicking on any of the green toggle switches. It's worth noting that this enables self-service capabilities for SMEs and business users. This eliminates the back and forth between business and data engineers. Pattern check. The software looks at every column and automatically recommends certain columns to be checked for patterns occurring in that column. For example, the column called Customer ID has the pattern of 3 alphabets, then a hyphen, and then 4 numbers. DataBuck will automatically discover what is expected in each column and track it. This same principle is applied for all the data validation checks. This makes DataBuck very powerful in detecting data issues that you did not even expect to see, which are commonly referred to as the unknowns. Let's click the Duplicate tab. DataBuck has a unique capability of being able to auto-identify the composite primary key in any file or table. Here, click on the arrow next to composite on the first row. The software shows the details of the composite key it has auto-discovered. In this example, 2 columns together make the composite primary key. Rearranging the runs to show the latest run up on the top, DataBuck displays the duplicate composite primary keys and the number of duplicate counts as well. So even if you have no idea what data the file has, DataBuck will help eliminate duplicates easily. Clicking on the Summary tab takes us back to the duplicate table. Here, below the composite, are other duplicates which were discovered based on just using user-specified columns. DataBuck offers enormous flexibility for all data validation checks. Here, the user can override, modify or specify the column or a group of columns to be checked for duplicates. This can be over and above DataBuck's automatic recommendation for this dataset. Now let's look at the Date Consistency tab. Tables and files often have multiple date-related columns, and this dataset had a few. DataBuck has automatically determined the relationships between the different date columns. For example, click on any of the blue arrows will show the details of the failure. In run 7, 2 failures occurred. Row 2 highlights a single record where the closing date and transaction date showed an unusual behavior. This was the only record from among thousands where the closing date was before the transaction date, which is unacceptable. DataBuck Auto discovered this expectation by analyzing hundreds of transactions from the dataset. It's worth noting that DataBuck automatically discovers relationships between not only date columns, but also all other types of columns, and makes them a part of the fingerprint of the dataset and sends alerts when those relationships are violated. Advanced Data Validations. Let's now click on the tab Advanced Results on the top. 6 kinds of validations are automatically performed on the data starting from record count anomaly to sequence. We'll explore a couple of these. Record count anomaly tracks if the volume of data is acceptable. Clicking the button Microsegment, we see how DataBuck tracks the volume of data for every microsegment individually. Clicking on any status will open up in the table provides historical trend information. Clicking on the tab Cluster Map, different microsegments and their expected volume of records are shown graphically. Let's look at Value Anomaly. This is what everyone commonly refers to as anomaly detection, even though there are 5 different types of anomalies. DataBuck detects all of the 5 different types. DataBuck has automatically recommended 2 columns to be monitored for anomalous value. From thousands of records, DataBuck identified 25 records where the loan amount had a low data trust score of just 2 out of 100. Clicking on the funnel icon can change the dashboard to display more richer and different information. We can see why DataBuck picked this record for loan amount to be anomalous within the microsegment Corp in USA. The expected value was about $415,000, but the actual loan amount was only about $4,000. This was much outside expected behavior for that microsegment. The user can give DataBuck feedback if they feel this is not an anomaly by clicking on the thumbs down button. It's worth noting that DataBuck's advanced 11-vector fingerprint technique eliminated over 80% of false positive anomaly alerts at a retail customer. This helped them reduce data maintenance cost and focus on addressing the true anomalies. Now let's look at anomalies in data distribution. Clicking the distribution button opens up the expected distribution of the different microsegments within this dataset. DataBuck automatically tracks the mean, the standard deviation, and area under the curve for every microsegment for every column. So here in Run 7, loan amount for the individual Canada microsegment was flagged as having a problem. We can click on the blue arrow to get more details. Every time DataBuck analyzes a table or file, it pushes the data trustability scores directly to the data catalog. It's worth noting that DataBuck's Open API eliminates custom configuration to connect to data catalogs. It provides contextually relevant, objective data trust score to the data catalog. This enables deprecation flags to be tracked along the data pipeline. In summary, DataBuck is a unified data observability and data trustability platform that can autonomously validate data at all points the pipeline. It uses machine learning to validate data at 10x less effort and 5x greater accuracy. It populates data trustability scores for every dataset to your data catalog with its Open API design. DataBuck has transformed the data pipeline of its customers by reducing error rates by over 80%, while reducing costs by over 50%. Automation with machine learning and Open API has enabled customers to shorten time to trusted data. DataBuck has multiple service partners. It connects with multiple data platforms, data catalogs and data governance tools with its Open API architecture. Visit our website or write to us for the free community version of DataBuck. Thank you.